Hi, buddy. This is Mr. Folly, Whoop. And let's hop right to it. So what we do on the molecularity of it is simply count how many reactants there are. So if there's 2, it's bimolecular. If there's 3, 2 plus 1, it's termolecular. This one has 2, it's bimolecular. This one has 2, it's bimolecular. My pen's being funny, so if you're listening, it'll work. Letter E has 2, it's bimolecular. Bimolecular has 2. This one has just 1, even though it's got a subscript of 3. It's one reactant, so it's unimolecular. It's got 3. Termolecular, 1, 2, 3. This one's got 1. It's unimolecular. So my answer key looks all kinds of shifted, but I think you can figure out what happened here. Okay, so for C, I think we're looking at how do we collide those specific structures. So I have NO, which I'll pretend it's double bond. And then we're going to have, ramming into that, ozone. Okay, and then you can see what will happen is it will just grab this guy right here. Probably not the double bond on that side. Just to, I do know ozone has a double bond, so we'll grab it this way, and that will give us the NO2 plus O2. Pretty similar thing happening with reaction D, where we have Cl plus CH4. And you're going to get a little bam right there, and that's going to give me HCl plus the ick CH3. Explain why a termolecular reaction is rare in terms of the collision model. 3 things must collide with enough energy and the right orientation at once, or really close to at once, instead of a simpler 2 or 1 reactant collision. All right. Here we go. 21. Use the rate law above to answer the following questions. What's the order with respect to that big dog? That is 2. Whoops. Good morning. That is 2 because the exponent is 2. What happens to the rate of the reaction if the concentration is doubled? So that means it's going to be 2 squared, 4 times faster. What is the order with respect to I? Number there, that's a 1. What happens to the rate of the reaction if it's doubled? 2 to the first, it would be 2 times as fast. What is the order with respect to H3O positive? Is 0. What happens to the rate of the reaction? 2 to the 0 equals times 1, which is the same. What is the overall reaction? I'm adding up my coefficients, 2 plus 1 plus 0. Trace. What would be the units of K for this reaction? So rate is molarity over second equals K times molarity cubed. So K is going to equal molarity over molarity cubed seconds equals man, I almost had it right without messing up. 1 over molarity squared seconds. Put tail below for the units of reaction K. If it's first order, it's 1 over seconds. I kind of like this because it makes me think. I'm going to put it outside the box because it shifted me. 1 over molarity seconds, and then 1 over molarity squared seconds. So you see the pattern pretty easily there. 23, determine the rate law. Okay, so it's always rate equals K, reactant 1, which is A, reactant 2, which is B, and we'll figure out the orders. Let's see here, 1 to 2, this is times 2, 4 to 16, that's times 4, so 2 squared is 4. This one, 1 to 2 is times 2, this is the same, right? This is times 1, that's 0. Determine the overall order for the reaction, so I would erase this. Overall order for the reaction is also 2. Determine K along with units, so my rate is 4E negative 5 equals K times 0.1 squared. Plus that calculator. So 4e negative 5 divided by 0.1. Ah, my 1 button's stuck. Oh no, how can I have a stuck 1 button? No. I'll try it again. 4e negative 5 divided by 0.1. Oh, you know what? I just turned away a calculator from a kind soul. I have 2 calculators. 4e negative 5 divided by 0.1 squared is 0.004. The thing is, that's totally doable in your head anyway. And then because it's squared, it's going to be 1 over molarity seconds. Determine the rate. Morning, everybody. Determine the rate of the reaction where A is 0.5 and B is 0.75. So again, rate equals K, which is 0.004 from what I found out right here. And then 0.5 squared. B doesn't do anything because it's 0 order. So 0.004 times 0.5 squared is 0.001. Still same unit, 1 over molarity seconds. When does K change? When temperature changes. Use the data below to answer the following questions. Oops, I just realized that I wrote this number down wrong. It's 0.05 squared, which will change my number. 0.004 divided by 0.05 squared, which is 1.6. Still same unit. All right, let's see if we can do. Okay, I'll pause. Deep breaths so my ink will catch up with me. Okay, determine the rate law. Doubles. Oh, man. Big number, 4.92 e negative 3 divided by small number, 1.23 e negative 3, which is 4. That's right, rate equals K. No H2. So when no doubles and the rate quadruples, it's squared. So now let's take a look at this one. This is times 2, and this is times 2. That's the same. That's first order. Overall order is the sum of those. Determine K along with units, so I'm going to just plug it in. I like the first one. 1.23 E negative 3 equals K. That's a 3. K times 0.1 squared times 0.1. 1.23 e negative 3 divided by 0.1 squared divided by 0.1 is K equals 1.23. It's third order, so it's 1 over molarity squared seconds. From the rate of the reaction when you've got that. Rate equals K, which is 1.23. Times 0.1, oh no it's not, 0.1 squared, and then 0.15 to the first. So 1.23 times 0.1 squared times 0.15 equals 0.001845. That's okay. And then the units are still going to be 1 over molarity squared seconds. And when does K change its value? Almost never. Only when temperature changes. Here we go. So determine the rate law. So again, what I'm going to do is look for a time when A changes and the other ones don't. So this is times 2. And this is, I don't know, 0.0174 divided by 0.0087. And that's 2. So again, you should always start off with rate equals K, A, B, C. So change was the same for both of them, so that's first order. I'm looking for one where B changes, but everything else stays the same. That would be 1 to 3. Okay. So on 1 to 3, I'm pretty sure, well, let's see here, 3.02 E negative 3 divided by 1.25 E negative 3 is 2.416. Ugh! 2.416. This is times 2.416. And my rate change here is going to be 0.0508 divided by 0.0087. And that's going to be, 5.839. Wow. Okay, so is that the same change? No. So that means it's not first order. Is that no change? Nope, so it's not 0. So I already know that has to be second order, but let's see if I can make that feel a little bit better. 2.416 squared. So 2.416 squared is 5.837. Okay, so it's like, whew. So see how that freaked me out for just a minute? That should be kind of okay. Let's check out C now. C would be from trial 3 to trial 4. Okay, so on this one, 3.75 E negative 3 divided by 1.25 E negative 3 is 3. So that's times 3. And then 0.457 divided by 0.0508 is 9. So that's another second order reaction. Now, I don't like this one. The reason why I don't like this one is the overall order of this reaction is ridiculous. The overall order of this reaction is 5. That means you need 5 things ramming into each other at the same time with enough energy in the right orientation. Ugh. Right? So that's not expected, but that's what it is. Determine the value of K along with units. So, I like to take the first one, 0.0087 is the rate, equals K, which is what I'm solving for, times A to the first, 1.25, E negative 3, times B squared, 1.25, E negative 3, times C squared, 1.25, E negative 3. And we'll see what our thing will come up with. Now, if I've got 5 for a power, it's going to be 1 over molarity to the 4th second. So let's see what we get here. 0.0087 divided by 1.25 E negative 3. I'm going to go crazy math here. Whoops, this one's supposed to be squared to the 5th. And I get 2.85 E12. That seems huge, but notice I'm dividing by something that's got an awful lot of negative, E negative something. So that should be huge. So I'm good with that. And that'll do it. All right, so 26. Use the data to answer the following question. So again, rate, first thing I do, rate equals K times H2O2, just a reminder because it's weird, is hydrogen peroxide. Peroxide is O2 negative 2. I negative and H positive. Remember, you can find H positive by pH, and that could change that way. Determine the rate law. So first thing, this looks like it's divided by 5, but really it's doubling. Okay, so looking at that exponent, if I took this one divided by that one, that's times 2. And then this guy is also times 2. Oh, I'm in a table, so it's being weird on me. So that's first order. That's not H2O2, that's I. So that's first order. If I want to do H2O2, I would do these. This is where H2O2 would be doubled. And then this is also doubled. Yay, mental math. That's first order. And then I have H positive, which changes here. So let's see, which one would I use? Oh man, I don't have one where because this one changes every time. So H positive is going to be a tough one, but we'll have to factor it out. Woo! How about that? So let's do these. Okay, so this is going to be times 2. This is the same. This is going to be times 2. And then let me check my math. No, that's going to be times 2. Okay, so I know that times 2 of it is because H2O2 is times 2. So that must mean that H positive's effect is times 1. Okay? So if anything's effect is nothing, right, times 1, that means this is 0 order. And I would leave that out. So I would not write that. It's not wrong to leave it, but I don't like to. I think it's simpler if you don't. Okay. Determine the overall order of the reaction. 1 plus 1 is 2. Determine K along with units. So I'm going to use the first one. And the only reason why I use the first one is so I don't like jumble it up in my mind. So my rate is 0.137 equals K. And then H2O2 to the first, which is 0.1. I negative to the first, which is 5, E negative 4. And I'm going to leave out H positive because it's 0 order, which means it changes to multiplying it by 1. So calculators assemble. 0.137 divided by 0.1 divided by 5e negative 4 is 2740. I've got molarity squared, so it's going to be 1 over molarity seconds. All right, so 27. Let's move her up. Even more trials now. Determine the rate law. Rate equals K, A, B, C. I had somebody ask before if I gave you real things like we had hydrogen peroxide and iodine, can I just change it to ABC? My answer is no, because you'll forget to change it back. So just whatever it is, put it in there right away and you'll be good with it. All right, so this first trial, hey, A is actually going to be the first trial. This doubles, same. This is times 4. So that means if I double it, it's times 4 at second order. So for B, same. This is times 3. This is times, why am I so worried? Yeah, times 3. That took me way too long to do. So that's the same change. That's first order. 3 to the first order is 3. To get 4, let's see here. If this is the same, these are not the same. Oh no, do I do that factoring thing again? I think I do. I don't want to do 3s because 3s are much harder on my mind, but I'm going to have to do 3 anyway. Yeah, so I guess I'll just do these because they're close together. This is times 2. This won't matter. This is times 2. And then this is, I'm going to go to my calculator for that. 19.2 divided by 2.4 is, of course, 8. So I know A is first order. So if this doubles, right? So the effect of A times 2 makes it times 4, right? So what I have left over, so the effect of C has to be the leftover. So overall, it's times 8. A causes the times 4, so C is the times 2. So when C doubled, and its impact on the rate was that it doubled, so that's first order. So again, this is an icky one where I have a fourth order overall reaction. So I said 4 and wrote 3, and I've got problems here. Boop. Okay, so determine the value of K along with units. So I'm going to use that first equation. 0.2 is my rate, equals K times A squared, 0.1 squared, times B to the first, 0.05, times C to the first, 0.02. And I'm going to have K equals 0.2 divided by 0.1 squared divided by 0.05 divided by 0.02, and that's going to be 20,000. I'm going to make that 3 sig figs, 2.00E4, and then this is fourth order, so it's going to be 1 over molarity cubed seconds. All right, so we have to write the rate law for each of these elementary steps. So if this is an elementary step reaction, the rate law, that means there's only one reaction step right here. So that just means rate equals K, A, B. And this is the only time, if it's an elementary step, that the coefficients are going to equal the exponents. So that's all I'm going to do is write rate equals K, A, B. And because it's an elementary step, that means there's one step in the reaction. So that means two A's have to hit at the same time as B to make that bad boy. So this is where we're going to use that exponents. Rate equals K, no, 3, and no coefficients. So that's done. Rate equals K, Cl, CH4. And I want to remind you that anything in brackets means it's in molarity. E, rate equals K, argon. Ooh, I don't like that because it's a noble gas. O3. And I'm looking at it, it looks like nothing really happened to it. I forget what the star means. Star usually means it's radioactive, so that's kind of a weird dude right there. A squared. See, I have 1A and 1A. I could write that as A squared, pretending that I can do math, because I can. Oh, I got a few more. Rate equals K, O3. O3 is ozone. I know I keep saying that, but it's a good word to know, kind of like you should know water's H2O. O and O2. Again, and N2. I almost missed that one. N2. Good. And then rate equals K, A. There you go. All right, so now 29. So this is unimolecular because this is 1. The elementary step would be A yields. This one has 2 and a 1. So that's going to be termolecular. So that means it's going to be 2 no's plus O2. This one has O2. It's bimolecular. So that's going to be 2 CO yields. This one has 1 of each. That's also bimolecular. So it's going to be A plus B yields. Hey, is that it? Oh, no, we got to do this. Explain the process of creating a blank. Calibrating spectrophotometer. Put distilled water into a, what is it called? Clean test tube. And measure absorbance. Explain why a blank is needed to calibrate a spectrophotometer. Subtract, the effect of water's absorbance. Explain the effect of fingerprint. Increases absorbance because light doesn't get through. Explain why the concentration of a color solution cannot be measured. No light absorbance occurs for a colorless solution. Let that be the end. It is. So that is it. I think we got them all in here. Sorry I paused. I hope it doesn't seem as jumbly as it was, but I will say this to you. Toodles.